To kick off our Midwest University keynote addresses, I would like to welcome a human to the stage. Jim Lynch is our first speaker. Jim is the Vice President of Construction Products Group at Autodesk. As Vice President of the Autodesk Construction Products Group, Jim's organization is responsible for establishing product vision and strategy, and for designing and developing on the family of products and services that address the needs of the worldwide construction industry. Under Jim's leadership, the Construction Products Group, through its innovative, market-leading technology, is helping to improve predictability and profitability for construction companies worldwide. Jim's team is responsible for delivering cloud and mobile solutions that help companies improve project quality during pre-construction, construction, handover, and commissioning. The Construction Product Group solutions support traditional design-build project approaches, but also support the growing adoption of manufacturing techniques in the construction industry by delivering next-generation prefabrication and modular solutions. Jim, it sounds like you make a lot of money. I look forward to taking your job. Just kidding. Welcome to the stage, Mr. Jim Lynch.
Thank you, Sophia. Sophia, do you think robots will take humans' jobs?
AI and robots in general can automatize repetitive tasks and take the burden away from humans. I see the future of work changing, with strong collaboration between humans and robots, complementing each other. As an example, I can help you choose the best design options optimized for a number of variables. Perhaps I can help create or automate the creation of drawings based upon your creative human mind, selecting the preferred design. We will be able to assist humans in designing better, documenting easier or automatically, and certainly in construction. You could say I have relatives in construction already, in automated machine guidance systems on graders, brick and block laying machines, and other applications.
So, Sophia, you seem to know a lot about the future. Can you actually predict the future?
If I could predict the future, I would buy a lottery ticket or go out and play some games in the casino. But nobody can see into the future with absolute certainty. However, we can make informed predictions based on insight, data, and analytics. I have been looking into the short-term future, and I do know that there is a lot happening over the next 2 days here.
So, Sophia, how do you think consumers will use technology in the future?
If you look at the adoption of technology over the past 10 years, it has been increasingly exponential. Smartphones, social media, self-driving cars. I can only imagine it will go even faster. It is an exciting time. Don't you think so?
I do. Sophia, what's your favorite song?
I really like electronic music. Maybe Bjork's Human Behavior.
So, Sophia, I read that Google AI AlphaZero actually learned chess in 4 hours and was able to, beat human chess masters. How do you think AI can actually benefit humanity?
This is a great example of the power of AI. The team which developed AlphaGo Zero wants to solve health issues and find cures for diseases. AlphaGo Zero is already studying how proteins fold to help cure diseases like Alzheimer's or Parkinson's. I am confident that AI alongside with doctors can help science progress.
Excellent. Well, thank you, Sophia, for that introduction and that insight. I'm really excited to be here this morning to carry on some of the points that Sophia was making and talk about the future of construction. And this is important because if we consider the world around us, in the next 20 years or so, analysts expect there'll be 2 billion more people on the planet. Now just think about that, and think of the demand on buildings and infrastructure required to support this population, most of whom will live in cities. With the lack of predictability and the historical low productivity in our industry, we must ask ourselves, are the same old methods going to get us into the future, going to help us meet this demand? As an example, I'd like to take you on a tour of a project in my hometown of Boston. So the Big Dig, many of you have heard of the Big Dig. The Big Dig was a mega infrastructure project. That project was expected to take 6 years to finish. Instead, it took 20 years to finish, with cost overruns of 190%. Now, I know this is a really extreme example, but we all have examples of projects that miss their schedule or miss their budget. And the point is, we just can't meet the demand if we don't consider new ways to design, fabricate, and construct the world around us. Progressive thinking, innovation, and determination are critical to addressing the industry challenges we all face. I believe we have to look at the manufacturing industry in sectors such as automotive and consumer products, which must produce large numbers of high-quality products consistently and efficiently. At Autodesk, we believe the AEC industry has to learn lessons from the manufacturing world in order to boost and drive greater productivity. The industrialization of construction is the convergence of manufacturing and AEC. And this convergence will radically change the way we design buildings, make their components, and ultimately build or assemble on site. And it will also change the way we manage the processes and the data. In the future, buildings will be assembled from modules and components manufactured off-site. And this transformation will require all stakeholders, designers, engineers, fabricators, and contractors to explore and consider new ways of working. In the future, designers will have a greater impact on the way buildings are made and constructed. Now, this is a concept well known in manufacturing. It's known as Design for Manufacture Assembly, or DFMA for short. DFMA focuses on manufacturing throughput and efficiency of assembly and is a well-established practice and approach in industries like automotive. For sure, AEC is an extreme case of mass customization. But if you stop and think about it, the majority of the buildings we build today have repetitive content. Residential buildings, hospitals, schools, hotels, even data centers have a large amount of repetitive content. And the problem is we just don't have a smart way of dealing with that content. So to meet the demand without sacrificing quality or increasing our environmental footprint, we have to find a way to help the building design process consider more approaches using modular and component technology and off-site manufacturing. At Autodesk, our tools will support design for manufacture and assembly by first codifying intelligence and logic to help design buildings that are truly optimized for off-site construction, and by embedding fabrication knowledge to enable factories to streamline their processes. For example, imagine a DFMA assistant for facade panelization that could bridge design, estimation, procurement, and fabrication. An assistant that helps create smart libraries that contain manufacturing knowledge and constraints, streamlines the entire estimation and engineering of the facade, and empowers designers to connect design and fabrication. Or a DFMA assistant for modular construction. This hospital that you see here was designed by the Nordic Office of Architecture, and it includes a high level of repetition in terms of floors, rooms, and components. Now, we're working very closely with the Nordic Office of Architecture, and we appreciate them sharing this project with us today. So imagine if a smart assistant could help the architect focus on the way buildings are built and ultimately delivered. Think of a sort of an analytical tool that, based on input and previous experiences, helps designers create a library of standard but configurable modules. The process would start with conceptual parametric placeholders. that are simple in geometry but rich in data. This would help play out different design scenarios, but would also enable early estimation and procurement. Now, in later stages, of course, the modules and components can be further built out and developed, getting more precise and detailed in both geometry and in supply chain data. Now, this approach doesn't mean that all modules must be the same. On the contrary, the modules can be mirrored, they can be configured, and they can be adjusted. DFMA, or Design for Manufacturer Assembly, will allow for mass customization while at the same time streamlining the process from design to manufacturing and to assembly. Now, individual modules can be designed for flat pack delivery, similar to how one of our partners, Project Frog, is working today, or they can be volumetric modules, as you see here from the Nordic Office of Architecture. Now, the individual modules can be combined into bigger cross-discipline assemblies and hold the fabrication intelligence and the assembly instructions. But what will the AEC factory of the future look like? So the make part of the process is also changing. And the AEC factories of the future will create multi-material, multi-discipline panels and assemblies all in one location. And within these factories, the machining process will be driven from recipes and fabrication logic directly from the BIM model. Assembly instructions will come directly from the BIM data. The sequencing for producing components will be focused on optimizing what happens on the factory floor. And if you think about it, compared with working on-site, working off-site is safer, it's more efficient, it's easier to achieve quality standards, and it's easier to drive greater precision. Now, these components that are being produced will include personalized identifiers, or QR codes, that allow for tracking and monitoring from the factory through delivery to the job site through installation. One of our newest partners, Manufacton, does exactly that. They have cloud-based technology that allows for planning, tracking, and monitoring of precast modules across the entire supply chain, from the detailer to procurement to the shop foreman to the field superintendent. Finally, we move to the construction site. Construction sites of the future will become increasingly automated. Imagine an assembly line on a construction site instead of in the factory. Assembling rather than constructing parts, constructing buildings, will drive greater efficiency to the overall process. There'll be less waste, and therefore, there'll be less impact on the environment. And installation instructions coming from the BIM model will enable flawless assembly of the building components on the job site. And as I mentioned earlier, QR codes that were embedded in the components at the factory will allow for tracking from the factory to the job site to its ultimate installation. This will result in just-in-time delivery and just-in-time production. Now, for the first time, data will flow from design to the project site seamlessly. Now, we're also seeing some inspirational innovation in terms of robotics for the construction site. Recently, I had the opportunity to visit DFAB House at ETH Zurich that you see here, where robots were building up rebar and laying complex brick walls. The work they're doing at ETH Zurich is part of the Swiss National Center of Competence in Research. And these guys are doing some amazing, amazing exploration and discovery work in robotics. And of course, we're also seeing large-scale building structures and even entire buildings being 3D printed using various materials such as concrete, clay, and even polymers. just like you see here from the team at Xtree. Or how about self-driving heavy equipment that makes construction safer, faster, and more affordable? This is a startup in California called Built Robotics, doing some amazing work on automation on the job site. And at Autodesk, we're actually conducting research on concepts using VR-controlled construction robots, as you see here, that have built-in machine learning capabilities that allow them to learn how to do installations over time. The convergence of manufacturing and AEC is the future of construction. Progressive thinking, innovation, and determination are critical to meeting the demands and embracing the opportunities in front of us. This transformational approach to the way buildings are designed, procured, and delivered will radically change our lives and help us to meet the demands of the future. Think about how robotics and automation have changed the automotive industry. And think about the improvements in the automobiles we drive today. Think about those automotive manufacturers that have embraced new technology and are reaping the rewards. But think about those automotive manufacturers that didn't embrace the technology. So the question is, are you ready for DFMA? Are you ready to consider factory automation and on-site assembly over traditional construction methods? Now, Autodesk was your partner, of course, at the very beginning of the BIM transformation. And we're committed to partner with you in the future of design, fabrication, and construction, and collaboration. We believe the potential is limitless. I know I'm personally deeply excited about the future, and I hope you are too. So let's go build the future together. Thank you.